Fourth graders, today we are combining two lessons, Module 3, Lesson 22, and Module 3, Lesson 23. And you can see that we are reviewing an old concept. We're going to be focusing on factor pairs today. Okay, and we're going to use what we know about division and the associative property in order to help us find factor pairs. The reason why we're reviewing factor pairs, even though we've learned about factor pairs already, is because it is super important for you to know about factor pairs and be very familiar with them as we move into harder division. Make sense? With your table group, remind each other, what is the associative property? Remember, when I associate with someone, I'm in a group with them. What does the associative property of multiplication mean? Go ahead and talk to your table group. As you'll recall, the associative property of multiplication says that if I have a multiplication sentence like 1 times 5 times 2, I can move these parentheses. I can say 1 times 5 times 2. And it's the same thing. Okay? Does that make sense? Good. You can see I have an array in blue there. Yes? Okay, how many rows are there going up and down? Everyone? 1. How many columns are there going side to side? 8. So this array right here shows the multiplication sentence. 1 times 8 equals how many dots are there all together? 8. What I do want you to write down in your notebook is the multiplication sentence. 1 times 8 equals 8. And I want you to remember that the first two numbers, the 1 and the 8, the two that are being multiplied, are called factors. And the answer to a multiplication is called the product. Make sure you label it. When we're talking about factor pairs today, we're talking about these two numbers together. When you have two numbers, that makes a pair. So 1 and 8 are factor pairs that make their factors of 8, the product. Does that make sense? Good. Go ahead and copy down this array right here. What multiplication sentence is represented by this array down here? Think to yourself, how many rows are there? Everyone?
2.
How many columns are there?
4.
Okay. So 2 times 4, and the product is going to be how many dots there are all together. How many dots are there all together?
8.
Good. So in this array, what are the factor pairs? Or what's the factor pair? 2 and
4.
Because these are the factors. And what is the product?
8.
8. Good. So you can see that both of these arrays have the same product. They both have products of 8. So by doing this, we have found two different factor pairs for 8. What are the factor pairs of 8 that we found here? Everyone?
1, 2, 4.
Oh, so you're listing, right now what you're doing is you're listing all the factors of 8 from least to greatest. But if I ask you what the factor pairs are, you're going to say 1 and 8, or 2 and 4. If I ask you to write a multiplication sentence, you would write 1 times 8 equals 8, and you would write 2 times 4 equals 8. Make sense? In your notes right now, point to the multiplication sentences that you wrote. Point to the factor pairs that you wrote. Point to where you listed the factors from least to greatest. Okay, we have 3 different ways of showing it. We have a multiplication sentence. We have factor pairs. Bless you. And we have factors listed from least to greatest. You have to be able to show it in 3 different ways like that. Okay? Good. What multiplication sentence is represented by the first array on the top? 1 times something, right? We got to count them. Count them in your head. Go. 1 times 18 equals? Good. When I wrote 1 times 18 equals 18, did I write factors, factor pairs, or a multiplication sentence? Okay, so I made an array of 18 dots where there's only 1 row. Next, I'm going to try if I can make it with 2 rows. Can I? You can see in the second example here, I have 2 rows. So my factors are going to be 2 times, how many are in each row? 9 equals 18. There's another multiplication sentence. In my third array, I want to draw, since I could do it with 1 and with 2, I'm going to try it with 3 now. Do you guys see how I have 3 rows? Draw an array that has 3 rows where you're using 18 dots. Basically, I want you to find 3 times how many dots in each row will equal 18. Everyone? 3 times? 6. So here we have 3 different multiplication sentences and 3 different arrays that all show how you can arrange 18 dots into arrays. Can we do it with 4 dots in a row? Can we do 4 rows, I mean? No, because 18 is not divisible by 4. What about 5?
No.
What about 6?
Yes.
We can. But that would be the same as if we turned this one on its side like this, right? So we've already done it. So now we found all the possible arrays and all the possible multiplication sentences for 18. So let's list out the factor pairs. What's one factor pair that makes 18? Sanvi?
1 times
1 and 18. Good. What's another factor pair that makes 18? Avani.
3 and 6.
Okay. Now, Avani, 3 and 6 is not wrong, but you're going in a way that will make it so that you might miss numbers. What should you have said instead?
2 and 9.
Remember, if we go in order, then we won't miss numbers. Okay? So go in order. Good. So those are the factor pairs. Evan, please list the factors of 18 from least to greatest.
1, 2, 3, 6, 9, 18.
Good. Do you guys see how once you have the multiplication sentences, you can easily do the factor pairs? And once you have the factor pairs, you can easily list all the factors from least to greatest? You guys see that? Good. I want you to think about arrays in your head. If I were to make 16, how many dots am I trying to make altogether? 16. Can I put 16 dots in one row like this?
Yeah.
Okay. And that's not really 16, but if I were to keep going. So what multiplication sentence would that be? 1 times
16.
equals 16. Okay. Since I could do it with one row, how many rows should I try next? 2. Okay, so it'd be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. I can do it. What would the multiplication sentence be? 2 times, 8 equals. To make a multiplication sentence complete, you have to write what it equals. You have to write the product. Okay? Okay, how many rows should I try next? 3. Let's try it. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Could I make it? Could I? Should I have known that I can't make it? How do I know? Because is 16 divisible by 3? How do I know that 16 is not divisible by 3? Anshul?
6 plus 1 is 7, and 7 is divisible by 3.
Yeah, 6 times 1 is 7, and 7 is not divisible by 3. So 3 didn't work. What should I try next? 4. Let's try it. Is it going to work?
No.
Is it going to work?
Yes.
Because 16 we know is divisible by 4. So this is why it's super important for you to know your divisibility rules and your math facts. Okay, what math sentence is represented? 4 times 4 equals. So, what are the factor pairs of 16? Sparsh?
1 times 16, 2 times 8, and 4 times 4.
Good. So if I just look at the factor part of the multiplication sentence, those are the factor pairs. That allows me to list the factors from least to greatest. Haruto, please list the factors of 16 from least to greatest.
1, 2, 4, 8, 16.
Good. We're also going to review what prime and composite means. At your table group, talk about it. What does it mean if a number is prime? And what does it mean if a number is composite? Go. Remember, we know that prime means that it only has 2 factors, 1 and itself. A number is composite if it has more than 2 factors. So let's talk about 23. What are some factors of 23? Let's list them out. Can we do 1 times something? 1 times 23, good. Can we do 2 times something? 3 times something?
No.
4? 5? 6? How are you guys knowing? You were just saying no, no, no. How do you know? How do you know it's not divisible by 3? You can't just say no. What do you have to do? Kashyap?
It's not divisible by 3 because 2 plus 3 is like no.
It's 5. It's not divisible by 3. Good. What about 4? How come you guys just said no? How do you know that 23 is not divisible by 4? Sparsh?
Because if it's divisible by 4, it needs to be even.
It needs to be even. Oh, it's not even. Okay. How do you know it's not divisible by 5? Yes.
The numbers don't end. The digit doesn't end in 0.
Ah. Do you see how you need to know your divisibility rules? If you don't, you're going to have a hard time. So 23 must be prime. What about 35? Is it prime or composite? I know for sure it's 1 times 35. But I see it ends in 5, which means I can do 5 times,
7.
which means it's composite. What about 48? I know for sure I have 1 times 48, but it ends in an even number, which means I must be able to do 2 times
24.
Good. Which means it is? I don't need to find all the factors in order to find out if something is prime or composite. Do you agree? As long as there's more than 2 factors, then it must be composite. We can also use math facts to help us find factors. Using math facts, we know that 28 is equal to 7 times 4. Okay. But we also know that 4 is equal to 2 times 2. Do you guys agree?
Yeah.
Do you guys agree?
Yeah.
Okay, go ahead and write that down. What if I grouped it like this, using the associative property? 7 times 2 times 2. Is that the same?
Yeah.
Huh?
Yeah.
Yeah? Okay, so what is 7 times 2?
14.
So does that mean that 14 is also a factor of 28? Yeah, because 14 times 2 is 28. Do you guys see how we use the associative property to help us find out that 14 is a factor? Right? So we can use the associative property by breaking up factors. We broke 4 into 2 times 2. Right? So rather than saying 7 times 4 equals 28, we can say that 7 times 2 times 2 is 28. And then we can use associative property to then group these two numbers together instead to find out that 14 is also a factor. Does that make sense? Let's use this knowledge to help us figure out if 3 is a factor of 54. We can also use division to find that out. Right? If I can divide 3 into 54, then it is a factor, right? So can I do 5? If I have 5 tens and I divide it into 3 groups, how many would there be in each group? 1. How many were used up? 3 tens. How many tens are left over? If I regroup those 2 tens, they become how many ones? 20. But if I bring down the 4 I already have, how many ones do I have?
24.
Can I do 24 divided by 3?
Yes.
What is it?
8.
So can I divide it with no remainder?
Yeah.
So what math sentence did I just write? I wrote 54 divided by 3 equals 18. How could I write this fact family using multiplication? Zara? How could I write 54 divided by 3 equals 18? That's a fact family, those 3 numbers. How can I write that fact family using multiplication?
You could do 18 times 3.
Equals?
54.
Okay. So let me ask you a question then. Is 3 a factor of 54?
Yeah.
Yes. So we can use division or we can use the associative property to answer if a factor of a number is factor of another number. Okay? Good. In order to use the associative property, we can first use what we know about math facts. We know that 42 is equal to what 2 numbers multiplied together? You should know this. Anushka? 2 times 21? Okay. That's one way to do it. Okay, is there any number that we can break up into smaller factors there? 2 is pretty small, so let's not do that one. 21's the same as? 3 times 7, right? Do you guys agree? So are 2 and 3 both factors of 42? Yeah. Is 7 also a factor of 42?
Yeah.
Good. Is there anything else we could break up even smaller? Not really, because 2 and if everything is a prime number, is 2 a prime number? Is 3 a prime number? Is 7 a prime number? If we break everything down so it's only a prime number, then that's the smallest we can break it down. Make sense? Good.